Hello and welcome to the presentation on the reciprocal system of theory by Dewey B. Larson, a universe of motion. This time we would be exploring the concept of reciprocity. I am Gopi Krishna and I will be guiding you through this presentation. So let's begin. First of all, what do we mean by the word reciprocal and where does it apply? Because in the postulates we have the phrase two reciprocal aspects. So let us try to describe what this means. First of all, let us assume that motion can be represented by a disk, of which one side is space and the other side is time. We represent space by the lighter color and time by the darker blue color. And both of them are two sides of the same coin. Now, space and time are reciprocally related to speed, which is an increase in space is equivalent to a decrease in time, and vice versa. Or in other words, an increase in the numerator is equivalent to a decrease in the denominator, and vice versa. What do we mean by the word equivalent? It is equivalent for our observation using the conventional reference system. That is, when we measure it, we see it as having the same magnitudes. This behavior of space and time are seen to be reciprocal of each other. Also, we can now write the equivalence relation where space is equivalent to the reciprocal of time. Let's try to understand this. Let us assume that the number of space and time units which we have in a motion are equal. Now, if we change the space units such that the magnitude decreases, we get a different speed or a different ratio. The same ratio can be obtained by increasing the number of units of time. As you can see clearly in the figure, even though the two sets of space and time are different in their sizes, the ratio of the lighter circle to the darker circle is the same in both the cases. This is what we mean by equivalence. A ratio, which is the ratio of space to time, remains the same in both cases. This is another example. In this instance, we are changing the number of space units in the bottom figure and changing the magnitude of time units in the upper figure. Once again, both the ratios are the same. Notice how the two have the same effect on the ratio of space and time. That is, the two have the same effect on speed. In the first example of the two, the speed is decreased. In the second example, the speed is increased. And in both the examples, this is done in two separate reciprocal ways. This is what we mean by the reciprocity between space and time. Now, we will examine the relation between spatial and temporal coordinate reference systems. Up till now, we were examining the reciprocity between space and time. Now we will examine how we measure the two reciprocally. First, let's recollect the two natural datum options. First one was 0 space per indefinite time. This was the usual origin of 3D spatial coordinate system. And the second one of the temporal coordinate reference system, we have the origin as indefinite space per 0 time. Let us take an example. Imagine the origin of the conventional 3D spatial coordinate system. The origin is a location of 0x10. Hence, space is equal to 0. There is no clock time associated with the origin. It has no definite value. When we measure something, the clock time is pretty much independent of what spatial value we are measuring. Hence, time is indefinite. The origin of measurements of space and time are hence 0 and indefinite respectively. Now, since the spatial origin is a specific location in this system, it is localized in the system. It is at a particular point, in other words. However, the value of clock time associated is of indefinite magnitude, as we have already mentioned. It can vary from 0 to infinity. So, if we try to represent this in the 3D temporal system, neither the magnitude nor the direction of time is fixed. In other words, there is no definite location. Hence, the spatial origin is non-local in this reference system. To rephrase, since the value of clock time is indefinite, the magnitude of time is indefinite, and so is the direction of time, and hence we have the non-locality of the spatial origin in the temporal system. The same happens with the temporal origin. So what this means is the spatial and temporal reference origins are mutually non-local. The origin of temporal coordinates is everywhere in spatial coordinates, and the origin of spatial coordinates is every when in temporal coordinates. To have another look at the reciprocal origins, on the left we have the 3D spatial coordinate system, where the origin is a single point, in other words it is local, and that very same origin, when we project it onto the 3D temporal coordinate reference system, or in other words we measure the same point using this system, we get a totally non-local distribution. All these points, every single point in the temporal coordinate reference system represents the origin of the spatial coordinate reference system. Now, another look at the same thing. We have a single point localized in coordinate space, and it is totally delocalized in coordinate time. So, to summarize, we have discussed two separate things as the reciprocal properties. First one was to show that the increase in magnitude of space or time is equivalent to a decrease in the magnitude of time or space. This was where we saw the reciprocal nature of space and time as related to a speed. Second one was to do with the reference systems. Origin of the spatial coordinate reference system is totally non-local in the temporal coordinate system, and vice versa. Thank you. This is the end of this presentation. Coming up next is Math and Euclidean Geometry.